One. Good morning, everyone. I am Aryan Tyagi.
And myself Ayush Kumar. Today we will presenting our case study and simulation of Intel Core architecture, one of Intel's most significant processor designs.
My presentation is divided into two main parts. First, a detailed discussion on Skylake, split architecture design, and unique features. And second, a live simulation where we'll demonstrate assembly programs running on an emulator.
So without further delay, let's begin with an overview of Intel Skylake architecture.
To start with, Skylake represents Intel's sixth generation core architecture launched in 2015. It's based on 14 nanometer FinF process, providing a balance between performance and power efficiency. It follows the x86-64 CISC architecture, which means it supports complex instructions but internally converts them into simpler micro operators for faster processing. The key goal behind Skylake's design were to increase IPC instructions per cycle, reduce latency, and improve energy efficiency across a wide range of devices, from laptops to servers. Now that we have a general understanding of architectures, let's move on to its design type and target applications.
Moving forward, Skylake belongs to a CISC family, but incorporates RISC-like execution internally. This hybrid design allows it to handle both complex and simple instructions efficiently. It was developed with versatility in mind, supporting multitasking, gaming, AI, acceleration, and video rendering. Skylake power Intel Core i3, i5, i7, and Xenon E3 processors aim to deliver consistent performance across all workloads. With that covered, let's proceed to understand the instruction set architecture that defines how Skylake operates at the machine level.
Instructor set architecture. The instruction set architecture of ISA or Skylake is based on x86 64-bit and includes advanced extensions such as AVX2, FMA3, and BMI1/2. It supports multiple addressing modes, which provides flexibility in how data is accessed and manipulated. For example, the instruction move EAX, EBX plus ECX into 4 plus 8 demonstrate dynamic memory addressing capabilities, allowing efficient data access during execution. Having understood ISA, let's now take a look how the data flows within the processor. That is data path and pipelining structure.
The Skylake pipeline consists of around 14 to 19 stages, which are divided in three major sections: the front end, the scheduler, and the back end. It utilizes out-of-order execution and features 8 execution ports, which allow multiple instructions to be processed simultaneously. Another key feature is micro OP cache, which stores decoded instructions, uh, enabling faster reuse and improving both performance and power efficiency. Now that we have explored how data flows through Skylake, let's move on to understand its memory hierarchy.
Memory hierarchy. Each one in Skylake as well organized memory hierarchy, including 32 KB of L1 instruction and data cache, 256 KB of L2 cache, and 2 to 8 MB shared L3 cache. It also supports DDR4 memory with a bandwidth of up to 34 gigabytes per second, ensuring faster data access and reduced bottlenecks. Next, let's talk about specialized features that make Skylake stand out in terms of um, parallelism and advanced processing.
Okay, so Skylake comes equipped with several specialized features such as hyper-threading, SIMD vector processing, and Intel SGX AES-NI for enhanced security. It also supports virtualization technologies like VTX and EPT, as well as TSX for transaction synchronization. These features together contribute to greater speed, multitasking capabilities, and security. Having looked at these, let's move forward to discuss Skylake multi-core structure and virtualization support in more detail.
Multi-core and visualization. Desktop variants of Skylake CPUs typically features 2 to 4 cores, while Xeon versions can scale up to 28 cores. The architecture employs ring to mesh interconnects, allowing efficient communications between cores and caches. An integrated memory controller further reduces latency, improving overall performance across parallel workloads. With that understanding, let's now look back at Skylake historical context and how it compares with other architectures.
Now let us look at historical significance and comparison. Skylake was the talk phase in the Intel's famous tick-tock model of processor development, representing a major architectural improvement. It paved the way for its successors, Kaby Lake and Coffee Lake, which built upon Skylake's foundation. When compared to ARM architectures, Skylake focuses more on raw performance and high processing power, while ARM prioritizes power efficiency. Okay, then. Now that we have covered the theoretical aspects, let's move on the simultaneation section of our presentation.
Now that we have explored the architectural details, it's time to see Skylake in action through our simulation.
We will be demonstrating two programs, Factorial and Fibonacci, both written for the x86 architecture to showcase instruction flow and control.
Okay, so I will be now demonstrating my program. Okay, so as you can see, I have opened a file. Now I will paste my code here, and now I will save this file. Here I click on this, and now the run. So as we can see, my program, which was to calculate the factorial of 8, is now successfully uh, um, successful. So this program will and now let's moving. Let's discuss our second demonstration, the Fibonacci program.
Okay, so now it's my turn to show how Fibonacci program works on a simulator. I'm going to share my screen, accept that request. Okay, so this is the simulator in which we are working. I'm going to run this program. First, I'm going to create a new file from here and I'm going to run that code. This is the code which I'm going to present. For this, I'm going to first uh, click on this. Where it is. First, I'm going to save this. It is being saved. Now I'm going to click on this. It is executed. Now I'm going to run this. So as you can see, the Fibonacci series has been implemented. The Fibonacci program generates the first 10 Fibonacci numbers using the add instruction and simple loop control. The output sequence, as you can see, is 011, 2, 3, 5, 8, 13, 21, and 34. This program basically demonstrates efficient data movement and iterative control flow with the x86 environment. You can see the output has been generated, and with this I'm going to stop sharing. Okay, so
So
with the
now let's
demonstration
jump back.
complete, let's conclude our presentation.
Yeah, let's jump back to our PPT. So in conclusion, the Intel Core Skylake architecture marked a major leap in Intel processor evolution, offering higher IPC, better efficiency, and greater scalability.
It laid the groundwork for future designs such as KB Lake and Coffee Lake settings, new standards for performance and reliability. This is it with our presentation. We have demonstrated the program on simulator and we have created the PPT for this.
Thank you for watching our presentation on the Intel Core Skylake architecture.
Thank you so much.